All right, here we go. We've got Blender stuff going on. There is a what? There's a problem with this script. So this is a little script I wrote. You can get it on blenderartist.org. You go in my sketchbook and you can find it there. And I guess I should put a link to that. Let's put a link to that into the description. Blenderartist.org. And where's my sketchbook? Notes, sketchbook. I think I can link directly to the post. Yes. This one right here. Make sure that works. Boom. I think I could even do that. Nope. Maybe I could do that. Yeah, there we go. Okay. I'll go in here. Here is here's where you can download the Blender script. Boom. All right, there it's in chat. So you guys can find it now. So this is a little script, and when you run it, it generates a spirally thing. And you can change the random seed, and you can change the number of steps, so it does more or less steps. I just think this is the coolest. I love how it does this. That's so fun. Ooh, that's kind of cool. Is that the shrinking is exactly right. Oh, that's interesting. 3.9. Let's see. 4. Oh, I got to get this exactly right. So then, yeah, look at that. Now it's tangent. 4, 1, just a little bit more, maybe like 3. Yeah, look at that. That's really cool. Oh, except it doesn't do it there. Why is that? Oh, it's because of the size scaling. All right, let's see. Let's add one of these. I've immediately become sidetracked. All right, so let's see. Branch smallness is 2. And it's also the time. So if a branch is earlier, so let's see, we want to set thrash to 0. Maybe. I don't know. I don't know what's going on anymore. All right, so anyway, you can randomize all this stuff. But one of the things that's a problem is that if you set the branching too high, like it ends up with tons and tons of vertices. Let's see. Steps. And then it gets all laggy. So I want to set, see now it's, yeah, exactly. Now it's getting all laggified out. I think it thought I was still holding down the scroll button on it. So now it's trying to create like 100 million vertices or something. So let's fix that. Let me fix this thing here. And close the program. Don't wait for it to respond. Open up Blender again. Recover the autosave. There. All right. And then maybe go back here. Is that working? All right, good. Got it back. Okay, so this is going to be, I want to add a feature that is max verts or something like that. And it'll just do a hard limit on the number of vertices. Random seed, steps. Let's see. How many steps? Main branch. Main branch vertices. How many vertices in the main branch? Maybe the number of in the main branch. Okay. Then we're going to have max verts, which is going to be the same thing, only it's in property, and this is default to, we'll say like 20,000, because that's when it starts getting kind of unresponsive. Main branch verts in property. This is min 1, sure. I think it needs to be min 2 though. Name. Maximum verts. Unsigned, the maximum number of vertices in the entire object. Okay. Then, because I don't have a good way of doing this, I could just pass self in. I don't like that. And it's still not, I want to assign, okay, so here's what I'm doing. So I'm going to say max verts, and that's going to go into here. Actually, we should not save max verts to the object. Okay, so one of the things I do in this is, oh, I need to run this just to register it. So one of the things I do is, you've got these two curves, right? And you want to make a new curve, and you're like, add object, and it saves whatever settings you used last. So like, this is the last one I made, but what if I want this one? Well, I added a feature, so if you select this and say add object, it copies the parameters off of this, and so now you've got all the parameters on here. But what I was thinking was, okay, and the way it does that is you go over to parameters on object, or is it on mesh? Mesh, yeah, custom properties. And it's right here, Deco Vine settings, here's all the properties. So, and that's just a, let's see, I'll just paste it down here. That's just a big long dictionary of all the settings that it saves. So it saves the seed, the max length, angle increment, all that stuff. But what I was thinking was, if you want to be messing around with designs and you don't want to have some sort of giant, nasty, monstrous curve in your settings, I'm not going to save the maximum verts setting, so it'll always default back. In fact, I think I'm going to set it so that it always sets to 20,000, even if we were using a higher number. So you have to reset it every time, because if you make this one giant one and then you want to make a small one, it's going to use the same settings. It's going to be a nightmare. So let's make that so it doesn't ever save it, and it always resets it back. So for resetting it back, we can do that pretty easy. Max verts, we'll do it down here. This is an execute, and this just gets called once because it says settings copied and sets that to true, and then if not, settings copied. So this only gets called once. I'm sure there's a way to do like an on-call constructor something, but I don't know how to do that. So I'm just doing it in the execute function. Object-oriented programmers, go eat a cake or whatever. Self.maxverts equals 20,000. So now, even if you have a different value that you used previously, it always gets reset to 20,000. Then we want max verts to also, so that's in here. It's already going to automatically generates a property value in the add object interface here for every property that you have in here. So I don't need to add it to the UI, but I do need to add it to the properties dictionary that I pass in. Branch rand, scale, verts, edges. I guess it doesn't matter where I add it. Verts. And we're just going to call it max verts. And we're going to call this max verts. And then I need to add it into the unpacker. And this is going to call this max verts equals max verts. And that way I don't have to copy each one of these things into the function. You can just copy it all as a dictionary. If you know the way to like do this all automatically, I just want to unpack all the quantities. You can see right here, it's just like every single one of these values is getting copied out to the local namespace. I was doing it with exec, but exec doesn't function on the local namespace anymore because Python decided that they would rather have it more performant than more flexible. So sadly, this does not work anymore. If there's a way to make this work where I can, because what I'm trying to do is just do this for every property in the thing. So anyway, but what I can do is I can make a copier that copies to existing values. And so that's what this is here for k in property. Exec self of this property equals the property with the key of that property for every key in the properties, which is imported from the Deco Vine settings property on the mesh object. So that's cool. So I don't have to add it here, but I do have to add it up there. And then I have to actually find where it's going to interrupt here. So that's max verts. And then we want to add a layer. So this is add objects, but what we really need is in Vine. Vine, we've got max verts. Okay, so now we're going to add a new vertex. We're going to recurse, reverse count 1, current angle, step scale. So this is inside the loop. So we're going to say if len of, or actually we can just say numverts, nmvts equals greater than or equal to, just in case we do something weird later, greater than equal to max verts break. That should break out of this loop and get us back. Actually, let's do it up here. Let's do it right up here. Number of verts greater than or equal to max verts break. So if we call this function, and at any point, no, except we can't do it here because we haven't defined numverts yet. Len verts. All right, well that's fine. We'll do it down here. Numverts greater than max verts break. So it'll break out of the loop, hopefully. So let's test it. Save it, run it, and add an object. Oh, it doesn't like it. Max verts is not defined. Oh, why not? Max verts, p max verts, and 133 and add objects. 113 max verts. Max verts. Oh, self.max verts. It's not defined because we don't actually, I was telling it to find in the local namespace instead of in the object's namespace. Okay. There. Now it's working. So now if we set this down to like something really tiny, should start erasing vertices off the end. Whoa, yeah, it works. And it erases them off the end. Oh, interesting. interesting, it gets one branch, so it gets one more. Oh, it's good that I said plus equals, so it gets one more than that. All right, so we can set this to 10,000 again, and we'll just set the reverse steps way down. And now, yeah, now the vertices are, let's see. Yeah, there we go. So it starts culling off branches. That's kind of neat. And then it's got all these little stubs here. That's very cool. That kind of looks like the hyphae on a like a mushroom, like a fungus, a fungal hyphae, where it has all these abortive branches, and then when it gets to somewhere where it can do some real damage, it starts busting out the branching. Anyway, that's kind of cool. And now we can do stuff where, let's see, what was there was something that like made it all goofball. Yeah, well, I guess this would do it. This would do it. It's got plenty of, so now we can increase these and watch it draw out these things. And there's another branch. Cool. All right, so that's interesting. And that works. All right, so great. So now we're not going to have a situation where it's running away. Oh, that's the other thing it'll do. So if we maybe make one of these and then say branch smallness. So this is the size, like how much shorter the branches get. And so if we set this down to 1, then the branches, each of the branches will be exactly as long as the main branch. But if we set this to less than 1, then it will start getting even longer. And so now it's, yeah, now it's started truncating stuff. Right. Boom. It runs away on itself. So now we can like reduce these. Yeah, so it runs away on itself. But now it won't run away on itself anymore, because it just goes and goes forever right in here. Ah, it's a fractal! I love it. A fractal spiral. Okay, cool. So that's neat too. I'm glad that works. Okay, so that was something I've been meaning to add for a while. Finally got it in there. Okay, so that is great. We've got a max length, so it's not going to run away on us anymore. What else was I going to add to this thing? I've got a bunch of notes. I've got a plan. So this is for my kitchen. I'm trying to put a kitchen together with some like decoration on the kitchen cabinets. And so here's some ideas for like different themes and stuff, and different, I don't know, decorations on there. But right now I'm just trying to get like the branching stuff to work properly. And I think, let's see. Oh yeah, reverse direction branches. So right now it only ever branches when it reverses direction. So if you look at this thing, for instance, you can see that what's happening here is that the main branch, well, it's easier to see. It's easier to see if I actually make the thing run, and then we can play with it. So if we set the branch probability down to 0, then you can see it's, there you go, it's reversing direction all over the place. Let's set this shrinking to like 1. No, that's not quite low enough. 0.9, 0.99. Okay, fine. So you can see it's reversing direction all over the place, and that's based on the reverse steps and the thrash. So if you set the thrash up, then it's higher probability of reversing direction, and reverse steps down, it is a higher probability of reversing direction. There we go. So that's kind of a nice one to play with. And then if you increase the branch probability, it'll start branching off. But you can see it's only adding branches where it reverses direction. So here, it's going this way, it reverses direction here, it didn't branch there, it reverses direction here, it did branch there, and then reverses direction here, so it'll branch there. And so if you set the branch all the way up to 1, then we'll get branches at every point. So it always branches every time. That looks kind of cool. So what I want to do is I want to add a feature where instead of branching only where it splits, it can also branch in the middle of a branch here. So instead of reversing direction and branching, it'll just add a branch without reversing direction. That's the idea anyway. So I think that's just a Boolean. Well, because I want to. What do I want here? What do I want? What am I trying to do? Reverse steps. Thrash 0. That's kind of cool. That's one of the problems with this, is that it's so fun to play with that I never want to actually get work done. Okay. That's so cool. Ah, I love it. I love it. It's so good. Okay. So what do I want it to do? I want it to add branches where it is not already branched and where the total angle has not exceeded what? Like maybe 180? Maybe a little less than that? What are these called? Buds. We're going to call these bud branches. Buds? I don't know. Small branches. There's so many flies in the house. I foolishly allowed my children to get guinea pigs, and now there are flies everywhere. Thanks, guinea pigs. All right, what are we going to add here? Self-scale reversing branch, branch scale, sub-branching probability scaling. Oh yeah, I added this. This is kind of cool. So this is the probability that the sub-branches will also branch. So you can have branches, but that never sub-branch. So then these all go off on their own thing, but they never sub-branch. Let's see. Let's do reverse steps down a little bit. There we go. So now these sub-branches will never branch themselves. That's really cool. Sub-branching, and then you can turn that up, and there's a higher probability that sub-branches will also branch. And so you set that up to 1, and pretty soon everything's branching off of everything. So that's a nice feature too. And then we can do the branch smallness. That scales back the sub-branches. What is this? Hang on, what is this? That's not right. You're not supposed to do that. What's going on here? What's going on here? Blender? I don't like it. I don't know what's going on there, but I don't like it. Is it in the console somewhere? System console. Nope. We'll leave that up just in case. Could you guys see that? Nope, you can't see it. That's fine. All right, so what is going on with that? How's chat doing? Nobody in chat. All right, good. I always feel bad when I go into chat and someone's asked a question like a half hour ago. I wasn't paying attention. But that didn't happen because no one's watching this. Is that? No, it's not from Max Verts. Okay, I see what's going on. So see this right here, this branch here, when I set this down, it jumps back to here. So I set this up, jumps up there, I set it down, jumps back here. So it has to do with the main branch vertices count. It has to do somehow with generating branches based off the origin instead of off of the end of the branch that is supposed to be branching from. That's weird. I gotta fix it. I gotta fix it. It cannot go on. Is it more likely with sub-branching turned down? Well, let's see. Let's see if we can figure this out. And then it goes away. All right, well, fine. Branch divisor, sub-branching. So something's happening in here somewhere that's using the wrong vertex. Sub-property. Branch scale. Step size equals step size. Current angle increment. Branch, branchiness. Vine. Sub-property. Countdown. Reverse threshold. Okay, so here's where it flips. Here's where it makes the sub-vine. And the sub-vine should always be based on verts.append vnext. Vnext equals verts minus vert offset plus next step. Oh! Oh! Yes! Right! Yeah. Okay. Vert offset equals 1. If this goes out of bounds, then the vert offset branching will go all the way back to the origin because the vert offset is equal to the total length. So what's happening here is, how can we view this? Oh, I know. I know how we can view this. We're going to add a build modifier. Okay. So you can see the way it's added is there's a central branch that goes out here, out through the middle, and it keeps reversing directions. But it doesn't add the branches. It doesn't do the main branch and then add the branches off the main branch. Whenever it reaches a branch, it generates the branch first, and then it comes back to the main and branches off. That's another thing I need to add after I fix this bug. So it adds these vertices branch first. It's width first, I guess, instead of depth first. So it waits until the very end to make the very end of the main branch. So the way I do that is each of these vertices has an index, and so it just starts at 0. Let's see, are these adding on? Yeah, okay, so they're not referring to the origin. They're not linking back to the origin, but they are offsetting from the origin instead of from the end there. So there's something going wrong with the offset. So these all refer back to the same vertex, so that they're not shared, or so that they are shared. Oh, I don't want that on. Edge length. That's, yeah. Turn that off, please. Okay. So you see they're shared vertices, so that they're all connected. I could do it so that each one of these added a new vertex where it branched, so that the main one goes off and then each branch one goes off separately, but I didn't do that. And I did it this way so that they're shared, so that it reduces the number of vertices slightly. Not a lot, but it slightly reduces the number of vertices in the mesh. And you can also do this with the connections, which I just love, especially when there's lots and lots of branching. When when you've got what? Come on. When you've got what? Verts. Let's see. Branching, sub-branching probability is higher. 0.93. Branch. Random length. Branch. Probability 1. Sub-branching. Branch smallness. There we go. We've got lots of different branches. And so now you can select somewhere in here and it'll grow back down to the stem and out to the end. And it's all very cool. So like you select something up here and then you can Control plus to add the selection and it goes all the way back down to the stem and then starts growing out the other branches. It's just really, I don't know, I love it. I love how it does that. So anyway, that's why it adds vertices there. So what I do is I keep track of, let's see, next step is vector. And this is just generating the vector for what direction everything's going based on sine and cosine of the current angle and z value of 0. We could add that too, so then it would all like spiral up, but I'm not doing that right now either. Maybe, eventually. If it's just branched, set just branch to false and set the vert offset to branch size. So what I need to do is I need to tell it just branched equals true, branch size, old verts. If random is less than branch, and we've got a sub-branch somewhere in here. Where's sub-branch? Branch, rand, branchingness. Find next. There we go. Branchingness. Self.branchingness. Branch probability scaling. Oh, I see. The branch probability is scaled by branchingness. Okay, so that's not quite what I thought. But it's still, all right, so we are still going to make a branch here. If flip. If random is less than branch, then reverse, then just branch equals true. So that should work. Why is that not working then? It's not the problem that I thought it was. All right, we're gonna add an object, and we're gonna increase the branch count. So this isn't causing a problem. Sub-branching. Branch 1. Reverse steps. That's kind of cool. Thrash. It's not causing the problem anymore. And there the vertices is 20,000. Perfect. Branch. That's kind of nice looking. but we're not getting the error. Okay, here's what we're going to do. Here's what we're going to do. We're going to repro it. We're going to repro it with the mesh because I've got all these meshes saved in here. There. That's the one that was causing the problems. Oh, this is so good. So now we should be able, fingers crossed, to repro it. Yes! Yes! Now we can repro it. Okay, so why does this one fail and all the other ones don't fail? What's going on here? Branch probability set to 1. Sub-branching is 0.21. So if we change this, does it fix it? No. So it doesn't have to do with the branch value. If we change this, does it fix it? Not really. So it doesn't really have to do with the sub-branching. It's something else. Branch length randomization. That does change it, but it doesn't fix it. Reverse steps? Nope. It's not a magic number in reverse steps. Thrash? Nope, it's not a magic number in thrash. Turning? Nope, not a magic number in turning. Shrinking. Well, that does affect it, but no, that's not the problem either. Is it the seed? No. The seed is fine. Well, now this is very strange. Now this is very strange. How do I get it to stop having problems when you have this kind of situation? It starts almost immediately. It's growing. Is it the main? It's the main branch that's having problems. Because I can see here, as I'm growing it, it's adding this out, and then it adds it to the end of the main branch, and then it adds some out, adds it to the end of the main branch, adds it out, adds it to the end of the main branch. And it also doesn't add the stub. Look at that. See, there's a little stub there. But the stub doesn't show up there either. There. So here, the stub is back here. And then we get a stub here. So it's the main branch is losing its place. When it's just branched off a previous branch. When the previous branch has... Oh, the branch length is 0. The branch length is 0. Branch length equals int all of this. Branch length. It needs to have at least I in range max length. Next step. Branch length equals max branch length, comma, 1. Branch length always needs to be at least 1. Also, the branch property should also probably equal, oh, it's times equal, so branchingness is fine. It's always going to be less than, it's always going to be greater than 0, because we're just multiplying it. As long as branchingness is greater than 0. Branchingness, yeah, min is 0, so that's fine. Okay. All right, that, I think will fix it. So let's find out. Run it. Add object. Now the branches always are at least one segment long. Yes. Yes. If we choose to branch, it's always one segment long. That is what the problem was. All right. Man, I'm so glad I implemented that copy settings thing. So now we've got this is exactly the same as this shift snap selection to active. So now it's exactly the same. Has exactly the same settings, but this one has the borked up endpoints, and this one doesn't, because we don't any longer have 0 length branches. Okay, good. All right, so now we're going to add that other feature I was talking about, which is separate. What is it going to be called? Separate branches. Let's see, it's a bool property, scale reversing branches. Let's put it right here. All the branch properties. Branch split. Now you get to see my spelling skills. Separate branches. Default false. Adds redundant vertices for branches so that all lines, so that points are connected to no more than 2 lines. There we go. Let's see. We can just delete that. Points connected. Let's see. Maximum 2 lines to each point. There. And then we do the same song and dance down. Oh no, not down here, up here. We've got max verts, we got step scale, branch split, self.branch split, and then up here we have branch split. I guess it doesn't matter. Branch split equals P of branch split. Okay. And then back here, when we branch, we're going to check the old, let's see, set state vine sub op. Okay, so we're going to get the old number of verts, old length equals len verts. Then we're going to set all these settings. So before we do that, right after we get the old length, we're going to say verts dot append verts -1. Is that going to create a pointer to the vertex? No, it'll create a pointer to the vector. Let's see. If, all right, so this is, it's not just appended, it's well, let's get it working. Let's get it working. Here we go. Add object, and this has a bunch of branches. And if we go in here, and we add it up, oh, that's interesting. That's all connected, but then those are connected. That's funny. That doesn't do what I thought at all. We want this to. Do we want it? Maybe we need to add it in. Okay, let's see what to add in here before we get the old length. Add object. All right, well now that's, nope, does the same thing? Doesn't matter. Well, it should matter. Verts append. Verts -1. Vert offset equals branch size. If just branched, branch size equals 0. No, it shouldn't. Old length. Are we not using old length at all? Branch size equals length of verts minus old length. All right, so we are using it. Branch size. Branch size equals 0, verts equals branch size, len, verts minus old length. Okay. So this needs to be +1. Length of verts. I feel like this should fix it. We're going to add a new vertex. Yeah. Old len minus old len. So if we add it in here, then that should fix it. Add object. It doesn't fix it. It doesn't fix it, but why doesn't it fix it? Okay. Add this in. And add a build. All right, so it's still doing in the same order. So it's adding out here. Then it starts adding out here. This is the old one. Oh. But now this, oh, I see. This refers back to this one, not to this one. If you just branched, and then now we have to go back to the old one. That's the branch size. All right, this is important. This is important. We're adding vertices. We want to come back with the main branch. This is working properly. this is working properly. But this one is connecting, instead of connecting to this one, it needs to go back two more vertices. So wait a minute, was this always not working? No, it was working before. It was working before. So we need to go back two more. Old length. So then when I add it after this, is it like 2 bars up? No. No, now it's working better. Although it looks like we haven't, looks like when we branch it doesn't rotate this first time. You gotta add that angle increment. That's another bug. Okay. That's another bug. So if the branch length is old length equals length of verts, then we're going to add another one. Now it needs to go back one more. It needs to go back one more. If branch split add another vert, old len minus equals 1. Yeah, okay, because it's subtracting old len. So it needs to be plus equals 1. It needs to be plus equals 1. Add 1 to the verts, add 1 to the old length. Okay, but there's another problem that we just discovered, which is that this should all be rotated around here a little more. What? Needs to be rotated around here more so that it's continuing this line, because right now it's just going in a straight line. So current angle increment is inverse. Current angle equals current angle minus angle increment. All right, that should kill both of those problems. Save it, run it, select it, add it. Okay. Now, this does correctly rotate more, but now this is adding on there. Oh, we never tested. And this is still okay. So we've got that disabled, but it's still adding on to there instead of to here. Was it? I thought it wasn't doing that before. It wasn't. It wasn't doing that before. Why is it doing that now? Maybe we just couldn't tell that it was doing that before. Yeah, it's in a straight line. It's adding onto that one. Okay, so I had an off by one the whole time. I had an off by 1 error the whole time. Old length should be length of verts plus 1. Or branch size is 1 plus length of verts minus old length. That's better. That way we're not, the old length is the actual length of the verts. Branch size is 1 plus. Okay. So now that should work here. All right, let's make sure this works. Add object. It's branching off properly. It's got the angle. And this is all connected. And this is... Yeah, okay, so now it's going to branch off a little bit differently because we fixed the way that it branches, but that's fine. So now if we add one with separate branches, looks exactly the same. But if we go into the mesh, hey, yeah, it separates off each branch. So the main stem, yes, is all one. And then each sub-branch gets its own root. And the reason that is important is because if you want to solidify this to make it look like something, we can add screw angle 0, screw 0.1, like that 1, and then we can add a solidify. And now if we set the thickness to, I don't know, 0.1 and this to 0, now each one of those is going to calculate properly. Oh, it's so beautiful. It's so beautiful. And now if we do it to this one, which has got the joins, we'll just do this, link, modifiers. This is not going to work properly because, well, actually, it doesn't do too bad. That's surprisingly good. But it's not going to be watertight. I did not expect Blender to be able to do that so well. Usually it causes problems when it does that, but that's actually really good. Okay, so maybe we didn't have to do that. Well, anyway, it's good that we have the functionality now, I guess. Huh, interesting. Learn something new. All right, well, good. That's just gorgeous. I love it. All right, and then if we do add object that thing, this should it's got separate branches turned on because this one didn't have the property for it. We can uncheck that. And now if we go back in here, we get proper curves for each piece. Yeah, there's no pieces straight in line, so we're not wasting any lines. Everything is nice and clean. And that's just great. And oh, maybe this will solve the weird problem with the branches scaling down. Ah, I wonder. That was... What was causing that? Yeah. I think, maybe? What was the branch smallness? Yeah. Yeah, because before we were parenting onto a previous vertex that was incorrect, and so it was making things look weird. But now it's perfect. Did I just solve that entire thing? I think I did. Yeah, before, when you added the length, each piece would scale down, but now it doesn't anymore. Oh, that's great. That's great news. I'm so glad that I added that feature, even though I didn't need it for the solidify, because now it's fixed that problem with the sub branches scaling down because they were parented to the wrong node. Cool. Branch smallness. Yeah. Branch probability. And it doesn't rescale anything. Oh, that's great. Sub-branching. Zoom. Oh, beautiful. Beautiful. All right. Well, that's great. That's great. Okay, good. I'm glad I got that fixed. Got the other thing fixed. We still haven't added the budding branches off, so let's try to do that. Oh, how are we gonna do that? That's kind of cool. That has a kind of bubble tank particle collider feel to it, doesn't it? Except it shouldn't be reversing direction. Ah, we can fix it with the reversing direction thing. Okay, neat. Neat, neat, neat. Let's make a new one of these. So that, oh, and then we'll fix this shrinking. We'll fix this turning to, let's see, we want it to turn a little more. There. Well, it's never going to line up perfectly. But that's pretty good. All right. Even more beautiful than before. Okay. Okay, good. Let's do budding branches. So budding branches, if random is less than branch, and then reverse count equals 1. Okay, so right now I've got reversing and branching in the same thing. But really, I want it to reverse and branch separately. So random get state. We need to get that. We need to get the old length. That's fine. If branch split. Okay, that's what we just added. Branch length. Branch length. Okay. Flip. Here's the flip direction thing. Here's the branch direction thing. So we want to take this out of the reverse direction code, which I think we can just do by doing this. Maybe. Angle increment is -1. Flip. Let's see what happens now. Random, rev count less than flip. Random less than branch. Okay. Yeah. Yeah. Okay. Nice. Okay. Great. Um, it works. We're done. Call it a day. Oh no, we can't do that, but that's kind of cool. All right, so we want to do two things. We want to do reverse steps and we want to do branch steps. We want to have the same thing here, but for branching. And then we want to have a toggle button that says always branch on reverse direction. So that's we're going to add that first. So if random is less than branch, yeah, yeah. Maybe I should make this like its own function. Let's make this its own function. Do we use I in here? We do use I. But that's the only thing that we need. Just branched is out here, outside the loop. Invert offset equals 1. Well, let's just try it and see what happens. What's the worst that could happen? Define a branch of I. And then we'll just take all this and we'll put it in oh, well, first off, that's not going to work because now we're clobbering our branch variable. So let's call this something different. So make branch. Make branch of I. There we go. Make branch of I. Let's just see what happens there. So we should be able to get that exact thing again. Add object. Okay, so that's not working at all. Good, good. I'm glad we had this talk. It's not getting the correct. It's not getting the correct branch size. It's not offsetting anything. Okay, it is adding the vertices. Now, branch size we shouldn't need because branch size just branched equals true. Yeah, that's fine. Just branched branch size. Reverse count, we don't need that. Random seed, we don't need that. Okay, maybe that'll work. You can tell I'm a real professional. Just trying stuff to see what works. Okay, that didn't work either. What is happening though? What even is happening? Well, it seems pretty obvious. It's not. just building it right out. It's just going right in line, but it's not resetting the branch size. Just branched. Make branch. Random is less than branch. Make branch. Old state. It's not revert offset equals branch size. Global branch size. Let's just see what happens if we do that. Okay, nothing. So it is setting branch size to something. And it is getting verts, like it's adding vertices, so we don't need to, I don't think we need to do this global thing. Make branch. This might be if just branched. All right, time for the ugly hacks. Print just branched and branch size. Okay, so it's still wrong, which is what we expected. We go over here, and it's still false in 20. So it's always false in 20. So it's not getting set. It's not getting set. So this isn't setting branched, but it is setting verts. Verts is defined up here. Vine. We get verts. Make a branch. Pass it in. Pass it in subproperty. Angle is right. How is it adding verts if it can't set the just branch flag? Make branch of I. If branch split is here. Well, that would be interesting to see if it respects branch split. I mean, it should. Separate branches. kind of. Ooh. That's kind of interesting. Goes back to the previous. What is going on here? This is very strange. Are each of these made up of 20 verts? No, that's made up of 7. That's made up of 5. It's making a new vertex, and it's making it in the right place. But then it's reversing direction incorrectly. Okay, what else do we have in here? Next step. Well, it doesn't have next step. I mean, that's pretty obvious. But it shouldn't need it. Just branched equals true. Let's see what happens there. Let's see what happens there. It's still false. All right, so that's still not getting set. So somehow it's still not setting make branch properly. Make branch is not setting just branched. What is up? Don't know. Okay. What are we doing here? Okay. If we just copy all this back. No, we never call make branch. So that should just work. Ooh. Huh. That's interesting. It's not copying the settings. Whoa. Maximum recursion depth. Separate branches. Okay, interesting. Does this not have the settings in here? It does have settings. sub-branching. It is doing it. Oh. Can I undo code changes? Yeah. Make branch. Copy. Make branch. Okay. That works. I don't know what was going on there. I pasted the code in the wrong place or something. Alright, so this is working, kind of. Although it is doing that weird scaling thing again. It's doing that weird scaling thing again. Why is it doing that? It wasn't doing that before. Old state, random set old state, so that's contained. Old length. Length of the verts list, that's fine. Branch split, we're going to split those off. Left. Max length minus I. Okay, so what else changes in this loop? This is all just set up for making the next vine subproperties. Make branch. Make branch. Exactly the same. Of I. So that should all work. Length left. Max length, which gets defined up here. That's also fine. Branch divisor, branch random. Branch random. Next step. Add the vertex. Number of vertexes. Number of vertexes. That's probably where the problem is. Equals 0. Let's see. Well, it's still not setting the, yeah, whatever. Let's see if that fixes something. Run it. Add it. No. Separate branches. Still wonkiness everywhere. Okay. Number of verts. Edges dot append. We can access the edges, so that's fine. Edges are up here. Verts are up here. Next step. Do we ever reference next step? Mm-mm. We could just make that. We could just kill this whole thing here. Save a variable assignment. Number of verts. Append. Number of verts. Okay, but is it inside make branch? It is not. So we don't know, we don't need to make that a thing. Edges, reverse countdown. Doesn't show up. Angle increment, -1. Reverse count equals 0. Recurse if branching on reversal. Reverse count plus equals 1. The reverse count isn't getting set to 0. That's something. That would be good to do. Is reverse count? No, reverse count is up here. And that gets set to 0 when we increment, when we recurse. Yeah. Baffled. Just baffled. Make branch. Do all this stuff. Recurse. Then set just branch to true. Okay, well, just branched. Branch size. Alright, so branch size should never equal 0. Make branch. Branch size. Where does branch size get set? Right there. So this is dumb, but now we're going to print them twice. Run it. Don't forget to run it. Ooh, there's a little lag there. Yep, true 2, false 0. True 4, true 12, false 0. So for whatever reason, the values are getting set here, but they're not getting set here. Just branched. True. Make branch of I. All right, well, here we go. This should fix it. I. And then we can change the I that we're passing to it. That's kind of cool. Although where is that used? Length left. I. Max length minus I. We want to find the variable I, not the letter I. It only gets used that one place. Should just pass in length left. Well, length left is only used to calculate branch length. Whatever. Max length minus I. Alright, save it, run it, delete it, add it. Okay, different problem, but different at least. Okay. Branch length. Branch size. Max length. Step size. Current angle, angular increment, branch. We set the branch probability down, so it's on branching. It's the same on branching. It resets the branch length to 0 or something. Just branch equals false. It's missing. Branch size. branch size. And length left. Verts. Right branch doesn't care if it's just branched. But when we call it next time, just branched should get redefined to false. So that's fine. Vert offset. It should be referencing vert offset. Vert offset is getting too big. Branch size. Make branch of I and branch size. And just branched. Oh, no, here we go. Just branched equals make branch. And then this returns true. Hey, hey. I feel so clever. Basic using return functions. Okay, well, great. Okay, where is my problem? Well, let's make sure we didn't break anything else. Oh, we did. We broke something else. Now, oh no, this is fine. It's as broken as it was before. Just use the default values. Okay, so it only goofs up on branching. Set that to 0 and it does just fine. It's kind of cool. All right. So we didn't break anything new. That's good. I and branch size. Make branch of I and branch size. Branch size. What else do we need? Just branched. Vert offset equals branch size. That should be all. Nothing should have changed there. Vert offset equals 1. Branch size. 1 plus length of verts minus old length. Old length is the length of verts. Print. Just branched. Which now, it still needs to be initialized to false. And branch size. So just branch should always be false when we're branching. Branch size, which shouldn't ever be 0. Well, it should be 0 at the beginning. Just branched, branch size, old length. I need to add a randomized scaled randomized. Countdown. To this condition. False 0. Okay, well, that could be the problem. Oh no, it shouldn't. It should only when it branch size should only show up if it's. All right, well, it is false. That's good, but it's always 0. Shouldn't always be 0. It shouldn't always be 0. That should be something else other than 0. Branch size. Okay. True and branch size. Just branched. And branch size equals make branch and branch size. Run that. See how you like that? Hey, it works again. Okay, it was that we were clobbering the branch size property inside the function for whatever reason. Okay. So, why is this so sluggish? It was so much faster before. Is it because it's calling random more often? I feel like it was calling random more often. Is it just because it's calling it twice? Seems like we shouldn't have. Seems like it shouldn't be so much slower. Is it just because we're not inlining this? All right, hang on a second here. Hang on a second here. Is this function call clobbering our... All right. Just branched equals false. Branch. No, see, I did it again. Yeah. Branch split. That's the problem that I had before. Ran less than branch. Okay. Then just branched equals true, and then comment that out. Branch size I. Okay. Maybe this is just my imagination, but it seems like this runs much slower. Okay. No, it's not. It's not a problem of... It is running much slower, but it's a problem of recursion or something. Okay, so that's good. just branched. If random is less than branched. All right, so we don't want if random is less than branched. We want if random plus rev countdown. Where's flip is less than flip? Branch plus rev countdown is less than flip. So this is the same thing here. Random plus BRCT down is less than branch. Just branched. Else branch countdown plus equals 1, and this is equals 0, and then we want rev countdown. Where's rev countdown defined? Reverse count. That's a little weird. Why am I doing it that way? Reverse thrash minus reverse count divided by reverse thrash. Oh. Reverse count. Okay, so we want reverse count to be incremented. Reverse count equals 0. Branch count equals 0. And then branch count equals 0 here. And then we're going to call okay, yeah. That's this. So it's going to be branch countdown equals BR thrash, yeah, minus branch, no, not branch count, reverse branch, reverse count. Ooh, boy. Branch reverse count equals minus branch reverse count over branch thrash. Okay, random plus branch countdown less than branch. So now we've got a branch thing, and we just need a branch thrash and branch. No, branch count is right. Branch count equals 0. So we've got reverse thrash. We're going to need BR thrash for branch reverse count, or branch reverse thrash. And then we're going to add that here. Self.branch R thrash. And then where do we want to add that in? To here. Separate branches, scale reversing, branch, length randomization, thrash, reverse steps, branch, thrash, branch, reverse steps. Branch branch length randomization. BR thrash is the same as thrash. Reverse steps. Oh, that's weird. Thrash. Flip is called thrash, and R thrash is called reverse steps. Oh no. Okay. Branch reverse steps also equals 17. Sure, why not? Min is 1. Yep. Unsigned step between branches. Branch scale. Flip is called thrash. Let's just call that flip. Step scaling. No. Shrinking is step scaling. Flip is probability of reversing direction. Okay. Flip. We also want something like flip. Branch probability. Okay. Reverse direction probability. All right, so that should all work now. Sure. Okay. It doesn't work. Branch probability 1. We gotta rename that. BR thrash is not a good name. Ah. Flies. Why flies? Branch. BR thrash. Okay. Thrash minus branch count. Else, oh, this has to be branch count plus equals 1. Yeah. All right, I think that was the problem. Think probably that was the probability. There we go. So if we set the reverse steps down, then we get more branching. It's always on the outside edge, which is cool. It'd be nice if we could do it on the inside edge. Do we want to be able to do it on the inside edge? Yes. All right, let's separate branches, make sure that still all works. Yes, it does. That all still works. Okay, cool. That's working great. We want to add a toggle for Boolean property, branch reverse steps. We want another Boolean property for branch on reverse. Branch when direction changes, question mark. No, that's way too long. Name is branch on reverse. Okay. Looks like bacon. Branch on reverse. Branch on reverse. And unpack. Branch on reverse. And then, if we branch on reverse, then, let's see, angle increment, reverse count. Then, if branch on reverse, and it's also the branch probability. Where's the branch probability? Branch, oh, that's there, less than branch. Branch on reverse. No, it's just gonna always branch on reverse. When you click branch on reverse, it's always gonna do it. No, it's not. If branch in reverse. And let's just we're gonna and rand is less than branch. I don't have any priority. If branch on reverse, recursive branching on reversal, then just branched equals branch size, blah, blah, blah. That's why we did that whole thing. And then branch count equals 0. Actually, we should make this branch count plus equals 1. Go back up, just branched equals false. If just branched equals false. Vert offset branch count equals 0. There we go. Now we don't have to do that anymore because we set the flag there, and now we don't have to remember to do that. Yeah. Okay. So that should work now. Oh, doesn't like it. Invalid syntax. I forget a comma. I forgot a comma. There. All right. Add object. Ooh. Branch on reverse. Now branch on reverse does horrible things. That's weird. But it only does it once? Okay. Branch probability 1. Reverse steps. Okay, so it's never gonna. Oh, that's interesting. It's branching twice? No. No, that's fine. All right, there. So now it only branches on reverse. And that's fine. It does reverse and it does branch on reverse. Is that actually? Yeah, it's actually turning. Okay, good, good. Just checking. Just making sure we didn't break it again. So it does branch on reverse. And we didn't set it to separate. And now it also branch. But now when it does another branch, it's just the main. Just the first time. Only the first time. No, because it does it here too. Occasionally, what is going on? It looks like the main branch is getting co-opted by the last branch in a chain somehow. We're clobbering vert offset somehow. Just branched equals false. Just branched and branch size equals make branch of I. Branch size. All right. Well, it sounds like everybody is back. So I'm going to stop streaming. And it's been interesting. More progress. I really wish that I had been able to make even more progress, but that's all I have to do for now. Thanks for watching, everybody. I'll see you later.